Imagine gazing into a crystal ball and catching a glimpse of tomorrow. The swirling numbers and visuals inside represent the vast potential of data prediction. That's the essence of data prediction, where raw data is transformed into meaningful insights. It's like having a superpower that lets us make educated guesses about the future using the power of information. This ability can guide decisions and strategies. Just as astronomers use telescopes to study distant stars, data scientists use data to uncover hidden patterns and make predictions. They delve deep into the data universe. Data prediction is at the heart of many amazing technologies we use every day, from smart homes to personalized gadgets. Think about how streaming services recommend movies you might like, based on your viewing history and preferences. Or how weather apps tell you if you'll need an umbrella tomorrow, predicting weather patterns with remarkable accuracy. These are all examples of data prediction in action, seamlessly integrated into our daily lives. By analyzing past data, we can make informed guesses about what might happen next, helping us prepare for the future. Let's dive into a simple example: predicting the height of primary school students. Imagine a classroom bustling with energetic children of different ages, sizes, and genders. We can use data to predict how tall each child might be in a few years. This might seem like magic, but it's actually a straightforward process based on logic and observation. We know that younger children are generally shorter than older children. We also know that boys and girls tend to grow at slightly different rates. By considering factors like these, we can make educated guesses about how tall each child might become. Let's say we have a data set of 150 primary school students, each with unique characteristics and backgrounds. This data set is like a treasure chest filled with valuable information about each child, offering insights into their individual profiles. For each student, we know their age, gender, and weight, which are crucial pieces of data. These pieces of information are called variables because they can vary from one student to another, providing a diverse data set. Our goal is to use this data set to build a model that can predict the height of a student based on their age, gender, and weight, making it a powerful tool. Think of this model as a simple machine, designed to process data and generate predictions. We feed it information about a student, and it spits out a prediction for their height, helping us understand and anticipate their growth patterns. Each variable in our dataset provides a clue that can help us predict a student's height. Age is an important factor because children grow taller as they get older. Gender also plays a role, as boys and girls tend to have different growth patterns. Weight can also provide insights, as taller children often weigh more than shorter children of the same age and gender. By combining and analyzing these clues, our prediction model can start to see the bigger picture. It's like putting together a jigsaw puzzle. Each piece of information helps us understand the overall pattern and make accurate predictions. Section 5. Building a prediction machine, a step-by-step guide. Building a prediction model is like baking a cake. Both require precision, patience, and the right set of tools. We need the right ingredients and a clear recipe to follow. Without these, our efforts might not yield the desired results. First, collect and prepare the data. This is the foundation of our model, much like gathering all the ingredients before starting to bake. The first step is to gather all the necessary information. This involves identifying the key variables that will influence our predictions. In our case, this means collecting data on the age, gender, weight, and height of 150 primary school students. This data will serve as the basis for our predictions. We need to make sure the data is clean and organized before we can use it. This step is crucial to ensure the accuracy of our model. Next, choose a prediction model. This is akin to selecting the right recipe for the cake we want to bake. There are many different types of prediction models, just like there are many different types of cakes. Each model has its own strengths and weaknesses. The best model for our task will depend on the specific characteristics of our data. Then, train the model. This is where the magic happens. This is where we teach our model how to make predictions. It's like putting the cake in the oven and letting it bake. We feed it a large portion of our student data and let it learn the relationships between age, gender, weight, and height. The more data it has, the better it can learn. After that, test the model. This step is like tasting the cake to see if it turned out as expected. Once our model is trained, we need to see how well it performs. We do this by evaluating its predictions against a set of test data. We do this by giving it a small portion of our data that it hasn't seen before and asking it to predict the student's heights. Finally, fine-tune the model. This is an iterative process. If our model isn't making accurate predictions, we need to adjust it. This might involve tweaking the parameters or trying a different model altogether. This is like adding a pinch of salt to a cake that's not quite flavorful enough. With each adjustment, our model becomes more accurate and reliable. Section 6. Data Science Jargon. Simplified, making sense of the complex. Data science can seem intimidating with its technical terms and complex algorithms. But don't worry, it's all about breaking down big problems into smaller, more manageable pieces. Think of it like learning a new language. At first it might seem overwhelming, but with practice it becomes second nature. Let's take the term algorithm. It might sound complicated, but it simply refers to a set of instructions that a computer follows to solve a problem. It's like a recipe that tells the computer what steps to take to predict a student's height. Section 7. The quest for accuracy. Why precise predictions matter. In data science, accuracy is paramount. Just as a doctor needs an accurate diagnosis to provide the right treatment, data scientists need accurate predictions to make informed decisions. In our student height example, accurate predictions could help schools plan for future classroom sizes, purchase appropriate furniture, or even identify potential health concerns. The more accurate our predictions, the better equipped we are to make informed decisions that benefit everyone involved. Section 8. Beyond the classroom, real-world applications of predictive models. The principles of data prediction extend far beyond the realm of primary schools. These models are used in countless industries to make critical decisions, improve efficiency, and gain a competitive edge. From predicting customer behavior in retail to forecasting stock prices in finance, data prediction is transforming the world around us. As we continue to generate vast amounts of data, the ability to analyze and predict future trends will become increasingly valuable in all aspects of our lives.